Okay, I'm seeing it looks like all of us are here. So welcome to today's webinar. Phomopsis, stem canker of sunflower, is fungicide resistance becoming an emerging problem? My name is Laura Isles. I'm one of the co-directors of the North Central IPM Center. We're one of 4 regional IPM centers supported by USDA NIFA Crop Protection Pest Management Regional Coordination Program. And like the other centers, we all have a mission to coordinate IPM across our region and across the country by promoting IPM research, extension, and teaching activities. So during today's webinar, if you have any questions, please type them in the Q&A part at the bottom of your Zoom screen, and our speaker will answer the questions at the end of the presentation. So our welcome today to Phomopsis from North Dakota State University, and I will let you, Kavina, introduce yourself anymore and introduce Jen.
Thank you so much, Laura. It's a pleasure to be able to present a research on behalf of the Sunflower Working Group that is currently funded to the USDA NIFA CPPM NCIPMC Center. My name is Phomopsis, and I am an associate professor at North Dakota State University. And I'm joined by Mr. John Swanson. He is the president of the Minnesota Sunflower Growers Association and also on the research committee for the National Sunflower Association, 2 important stakeholders that we work with hand in hand as part of a sunflower working group, as well as sunflower research activities. So before we get started, I want to just give a sort of like a perspective about why this particular topic was chosen for the webinar today. And that's primarily because for 2 reasons. One, sunflower is an important crop for 3 states that's grown in the North Central region, Minnesota, North Dakota, and South Dakota. And we talk about 80% of the production that takes place in the United States. And the United States is in the top 10 for production of sunflowers. And another is a disease that was possibly ignored for decades since its first report. And then it just appeared with a bang, compromising yield primarily in Minnesota, North Dakota areas with a 40% yield loss or more. It affected not only the farmers, but also the industry nurseries where they were trying to breed for resistance to other diseases. So with that, I'm going to have Mr. Swanson give us more like an historical perspective of this disease, which was first reported in the 1980s. So he was possibly the first person to see the disease in Minnesota, or probably in the United States. John?
Thank you,
and I was wondering, like, when you saw the disease first, now that we know Phomopsis, for instance, a lot of the diseases that we see can mimic symptoms of Phomopsis stem canker. It looks pretty much like these. What was your take at the time when you saw the disease the first time, and what were your immediate thoughts? We have a problem, or we don't have a problem?
Well, I think going back to it, a lot of people were thinking it was sclerotinia going in on the leaf and going into petioles. But the difference is if you run your fingernail or a knife really just on the brown part of the stalk there, it'll be green underneath if it's Phomopsis, and it'll be darker color if it's sclerotinia. So there was when I first found it, I didn't know what I had, and I went to Dr. Gulia with what it was, and I guess I'd been in Yugoslavia and Romania prior to that and seen it over there, and in France, they were having a problem in parts of France at that time with Phomopsis, and I was pretty sure that that's what I was seeing in some of Minnesota and North Dakota. As we went along a little bit, well, just back up a little bit, I started working with sunflower in 1971, probably before many of you were even born. I started out as a fieldman and then worked in research and international marketing and developing hybrids for the international and domestic market over the years. And I ran a testing program when Land O'Lakes bought out Dahlgren and Company, and my boss asked if we wanted to start a research program or what we needed to do, and I said, I think we should run a really good testing program rather than a research program. And so I was running trials for, I think, about 28 countries or 28 companies, some of the leading companies around the world. We also had in there, now this is getting to the mid-90s time frame.
Sure.
At that point, there was a variety in Europe called Albania that was pretty much immune to Phomopsis in Europe. So I got samples of that hybrid from, well, actually a sister company that at that time we were part of Sanofi, which had a pretty large sunflower operation and research in Rustica, and they owned the rights to that variety for Europe. So I put it into our trial as a Czech variety, and lo and behold, it wasn't only somewhat susceptible, it was the most susceptible of anything in the trial. Well, I put it in as a Czech variety, so it was in 3 or 4 reps in every one of the 28 trials spread over 13 locations. And the breeder said, well, I think you made a mistake. I think it's got to be that you just mixed this up. I said, well, I know I can make mistakes, and every researcher has made mistakes in planting and note taking and all that, but
Yep.
You don't make the same mistake 13 times 4 times 28 trials. That's too many times to make the same mistake. Not
Right.
very likely.
Yep.
But when you first see the signs of it, and as it turned out, it was the most susceptible in the trial. And that kind of was where I found the strain called Gouliot was in Minot trial, where we had materials from parts of the world that were supposed to be resistant a little bit later than the Albania trial. And then again, we had another one that was much more susceptible than most of the product. And that's when the new strain of Goulia, he wanted to name that after me, but I said, I don't need to have a disease named after myself. I prefer not to have that.
Right.
It's hard to sell sunflower with the way it was without having a disease attached to your name.
Right.
But I would say that Phomopsis is the most limiting factor in Minnesota for production,
Sure.
more so than Sclerotinia economically, and has been for maybe 25 to 30 years. So it's been around for a long while. We need resistance from the breeding program, and we need a way to combat what's not immune to the disease with some kinds of fungicides. So that's where Sabina's work is coming in to be really important to the industry.
Sure. So thank you, John. So I was also wondering during that time when Phomopsis was identified, the disease was sort of dismissed off because it just was a minor disease among the other diseases that was prevalent in the 1980s, like Sclerotinia. But then when it showed up in 2010, as in the form of a disease epidemic, primarily the regions, Minnesota, North Dakota, South Dakota. I remember that I was a graduate student at the time. So we had just, I remember Sam and Tom Goulier talking about, we have an epidemic now in Roseau, Minnesota. That was where a lot of the yield was compromised. And was that what you saw in 2010? Maybe, is it comparable to what was in the 80s, or was it a little more than, from your visual observations?
Oh, I think it was more because I think the inoculum built up. But we had some wet periods, and it tends to be a year where you have damp, humid conditions with moderately warm temperatures when we see it worst. I can think of Roseau area and also in Monoman County, which grew a lot of acres back then. And they were calling it all Sclerotinia, and I think Phomopsis was equally as bad, maybe even worse than the Sclerotinia. But most of them were thinking it was the petiole or the stock Sclerotinia that was going in and causing the breaking of the stalks. But when I went out and checked, there was Phomopsis in almost all of the stalks, and sometimes had Sclerotinia. So sometimes they had both diseases at one time.
Sure. Yep. Thank you, John. So as we look into a field that may be affected by Phomopsis stem canker, this picture is basically from my trial in Brookings, where I was at South Dakota State for 8 years. And anytime a susceptible hybrid is planted, we typically tend to see the sunflowers starting to lodge at least 2 months before harvest. And so those are sort of like difficult to say if it is Phomopsis at the time. The sclerotinia can also do, and it loves the same conditions as Phomopsis, but it's very typical to see that these plants are starting to die out, mostly prematurely if the infection is setting fast with wet conditions, but before just 2 weeks before harvest, this is how it typically looks like. There's also a reduction in head size. So the big giant heads are just normal sized for sunflowers, but the ones on the other side where the head looks pretty small, that's again harvested from the plants that were affected by Phomopsis stem canker. So essentially the seed setting kind of is much smaller. The seed diameter tends to be smaller. As a result, what happens is the farmer starts to see at least a 40% yield loss, but it has also been documented that there is a reduction of a 10% in oil content. So those are the economic losses that we would typically see from Phomopsis. Now, on every bi-yearly level, we do have a survey that is coordinated by the National Sunflower Association. And over the years, we are seeing an increased prevalence in this disease. So for example, in 23, it was a 44% was reported in the region. And that is primarily, again, because of the wet conditions. So this is sort of like a late season disease that usually appears on the sunflowers, maybe like a month and a half before it is harvested. And some more data that we have clearly indicates that the worst affected regions tend to be the top sunflower producers in the US, which would be Minnesota, North Dakota, South Dakota. Colorado, there's a small pocket of production. Again, the incidence was fairly high, and there was the first time the disease was documented. But in states, if you go down to like Texas, for example, we're not going to see much of this disease. Nebraska or Kansas, because they tend to be much warmer when it comes for favoring this particular disease. So what we have done since the 2010 epidemic, we have been researching pretty high into looking at management strategies. And as I indicated in my talk early, we work hand in hand with the stakeholders, because anytime we set up trials, we do work with our industry partners or the farmers, and we try to find locations where Phomopsis stem canker is already present in the field, meaning there's a history of Phomopsis in the field. So some of our work that was published in 23, this is by my former student, Ruchika Kashyap, in collaboration with Sam Orkel at NDSU and Bob Harvison at UNL. We established that QOI fungicide, Quinone outside inhibitor fungicide, specifically pyraclostrobin, when it is sprayed at a specific growth stage, which we call R1, that is when the floral head starts to form, is effective against the disease. Now, well, with the use of QI, it was a big success for us because we identified the timing. We also identified what fungicide was going to work. We also started recommending to the farmers as to when to start spraying. But then we also noticed that there are other side of using QIs, which is not very uncommon in other crops like soybeans, for example, or anywhere where QIs are used. But in sunflower, this was sort of a little bit of a surprise, given that the crop's not all that major compared to, again, soybeans. But the use of QI fungicide might given some other pressing issues, because if the fungicide were to be used not consciously. So what we did, and this was again, this is a work that was done by my current student, Kartika Mohan, at South Dakota State, and then she moved with me to NDSU. What we looked at to see was if the strains were already starting to show some sort of an insensitivity to the QI fungicide. QI fungicides are traditionally known to have a high risk of fungicide resistance development. There has been several pathogens reported already to have resistance in general, but in sunflowers, this was not really a case that was heard of. So what that really means is this is, again, a greenhouse study where we did some in vivo screening. So we used the industry standards currently on the QI labels against sunflower. We use the application rate of 6 to 15.5 flower lawns per acre. So if the isolate is sensitive, then it is, as we increase the rate, we should basically see lower disease. But if the isolate is not sensitive, it doesn't matter that we are spraying fungicide, we're going to see the disease level to be similar to a control where fungicide is not sprayed. So that led us to be screening isolates from North Dakota, Minnesota, and South Dakota and Nebraska onto the greenhouse, onto the sunflowers grown in the greenhouse. The temperature was set at a time at a range that the fungus can cause infection. So we were able to see varied symptoms, which is an indicator that the experiment worked. And then we took it a step further, where we decided to sequence some of the isolates that we classified as insensitive. And for molecular assay, usually how we do it is that we extract the DNA, and we do have a primer that amplifies the cytochrome B gene region. The QIs are traditionally known to inhibit the gene from activating, as a result of which the fungus is not basically able to breathe, and as a result, over time, it just tends to die. So we look for ways to amplify that particular gene to see if there is a mutation. If there is a mutation that happens at 143 position in the fungal gene, that's a cytochrome gene, then we call that isolate to be resistant. If there is no mutation, then it is classified as sensitive. So upon running a molecular assay, we were able to confirm one of the isolates to be resistant. And as I speak, we are currently continuing to use the cytochrome B assay to see if there are other isolates or strains out there that might be resistant to the fungicide. So this was the first case of fungicide resistance in sunflowers for a foliar pathogen like Phomopsis. And this is specifically on Phomopsis helianthi, which is one of the more prevalent pathogens capable of causing Phomopsis stem canker, at least in the United States. So we're continuing to get samples from farmers, and we are trying to determine the prevalence of these fungicide-resistant strains in Minnesota, North Dakota, South Dakota. We're also getting stocks from Kansas, Nebraska, and Colorado. So that is a project that's in progress. Now, since we are paying penalty by using QI fungicides, which generally carry a high risk of resistance. Already 30 plus species or pathogens have been documented to have resistance. We know that this fungicide is not going to be effective against the strains or Diaporthe in the long run. So we started, there were two things that we did. One, we started to look at some fungicide resistance management. So we wanted to educate the farmers on why it was important that we limit the use of QIs, because we do not want the resistant pathogen population to start building up. And if you are using QI fungicides, you may want to preferably use it in mixture with another fungicide that has a different chemical group, if available. Now, one of the limiting factor, like in any other crops, for sunflowers, we just have 3 FRAC groups. FRAC meaning Fungicide Resistance Action Committee. We've got 3, and those are 3, 7, and 11. 3 would be your QIs. 3 would be your triazoles or the DMIs. 7 would be your SDHI, there's a succinate dehydrogenase inhibitors. And then finally 11 is where your QIs. So we are limited also on chemistries when it comes to sunflower. So keeping that in mind, our next objective, and this is again done by my graduate student Karthika Mohan, what we're looking at is determining if there are alternate fungicide chemistry that might be effective. And if it is effective, what timing can we potentially use for managing Phomopsis stem canker? So what we did, we started some trials, but we also did some meta-analysis to see if we can sort of determine the right growth stage. So we conducted field trials in the 4 states, Minnesota, North Dakota, Nebraska, South Dakota, for a total of 87 location years. So we are pulling it from 2009 all the way up to 23. Again, this is just a meta-analysis. That's why we have so many location years. We used the 3 chemistries that are labeled on sunflowers. We included a non-treated control where we had no fungicide sprayed. We typically do ground applications, especially in our research farms, but there are farmers that do use aerial sprayers for sunflowers. And then we evaluated the effectiveness of fungicide using disease severity as well as yield. So we get commercial seeds from companies, specifically new seed for a susceptible hybrid. And there are years when they have some good breeding lines. We do get some resistant lines, but mostly the trials were done using susceptible hybrid. We do mix the fungicide with 2 types of adjuvants, the non-ionic surfactant and as well as the crop oil. And we use 2 types of sprayers in our farms. Not on the same farm. I had a high-boy sprayer at South Dakota State, so we sort of used a high-boy sprayer of this sort to spray over sunflowers. And then the other most commonly used mechanism would be our traditional backpack sprayer. The key thing to note here is so this gentleman here is about 6 feet. The sunflowers are probably half a size already. So sometimes there is a little bit of limitations when we try to spray fungicide. The coverage may not be the perfect because the crop's a little difficult. Compare that with like soybean or maybe corn or any other crop that you are familiar with. And what is most important that we have determined for Phomopsis is hitting at the right growth stage. So this is what we call R1, where the floral head is just starting to form on the head. It has not come out. It's just still sitting on the head. And we try to get the fungicide right over that head. So if it misses that head, then there is no guarantee that the fungicide is going to give us the yield benefit that we are looking at, which I will get down in a little bit here. This is again the high-boy sprayer. You can see the nozzles that were used were flat fan nozzles, which is very commonly used by growers. And again, we try to get that nozzle right over the sunflower head at that point to spray the fungicide. So growth stage is a little tricky on sunflowers. It's a pretty long season crop. Like usually in the Dakotas, we plant between May, June, and harvesting happens end of September into October, depending on the maturity groups. So it's one of the last crops to go in as well as one of the last crops to be harvested. What I have here is just to show the time it blooms. It's R5, and I call it the selfie growth stage because anytime sunflowers are in bloom, you can see a lot of people coming out taking pictures. So when we spray is approximately a month before that bloom happens, and that's the timing that we try to target. So I'm not going to go too much into the statistics, but if you follow along the asterisks against the 95% confidence interval, we sprayed it at 3 growth stages. So we did a late vegetative. R1 is the growth stage that we were targeting on, and R5 is our selfie growth stage or the bloom stage. And then we did some sequential applications with different chemistries over the years, and we found 2 growth stages to stand out. So of course, there's a difference in the number of trials that we did, but this is again analyzed using meta-analysis. We use the R1 timing. That's again when the floral head is formed on the growth stage. And then an R1 plus R5 timing seems to be significant if we were to see the effectiveness of fungicide against the disease caused by Phomopsis. And same with the yield, we were seeing some level of yield benefit at these growth timings. So we sort of kind of got a hint that if we were to spray fungicide at R1 or R1 and follow plus R5, we are going to see some yield benefit, plus it was going to reduce the disease caused by Phomopsis. The next step was we tried to look at some of the active ingredients, and the meta-analysis again showed anything that contains pyraclostrobin at R1 seems to be working at this time. Again, this is purely based off yield, but we did try the other chemistries that is already labeled on sunflowers, but there wasn't anything promising besides the pyraclostrobin. But there are a few other QIs you can see that was not really significant, that was when we kind of wondered if the QIs are truly effective or is it just this one particular active ingredient. And that's how this whole fungicide resistance story began. Same again with the disease severity, which we're seeing pyraclostrobin to be effective. And so the question really then for us was, is fungicide resistance going to be a big problem? Because we've confirmed it in Minnesota for the first time in the US. We don't know of any other reports, even in the world, where QIs QI-resistant strains have been detected. So before we wanted to be a problem like we see in other crops, we decided to get on with the other chemistries to see if there was an effective solution around it, or if we can find a fungicide partner with headline or Preaxor or anything that contains QIs that was going to be effective in case the QI-resistant strains are present. So the Luna Experience is a product that's from Bayer. It has triazoles plus the STHI, and we decided to do some studies to see, okay, if we were to use that and partner it with headline, if we were going to see any differences in yield when compared to the no fungicide control. So this was a randomized complete block design, a trial set in 4 locations with 11 treatments and 4 replications. So we did it in 1 location in each state. In Minnesota, we didn't quite find any differences in yield and non-treated control. The application timings was sort of changed, but we tried several sequential applications and compared it with no fungicide control. In Grandin, though, we observed that the 1 application of pyraclostrobin with a single application of fluopyrim plus tebuconazole, and that's what the Luna Experience has led to a 10% yield increase, although statistically it was not significant at alpha 0.05. Scotch Bluff, we were seeing maybe early application of Luna Experience with pyraclostrobin was giving us a 16% yield increase. We didn't see a lot of differences at a later application. And in Brookings, we did see that it was significant at 0.0005, and we were seeing up to 30% yield increase when this Luna was sprayed at R5 after spraying pyraclostrobin at R1. So for sunflowers, typically, when we say that the application might be working, we're looking at approximately 2,000 pounds per acre is a good year for farmers. The prices can be high for sunflowers, at least in the last 10 years. We're looking anywhere between $15 to $25 per 100 weight. And that's because we have a range, since we have 2 classes of sunflowers, oils and confections tend to be priced higher. And for a farmer, typically when he has to add he or she has to add a lot of the cost in pre-planting, post-planting, soil analysis, fertilizers, the emergence, pre-emergence, post-emergence herbicide, maybe use of an irrigation, cost labor, it will be at least a $700, which they have to put down per acre. And so if I were to judge looking at this, if it is profitable to use pyraclostrobin, it is, because we have some studies that have done the economic analysis to show that for a farmer, the probability that it's going to not or give a break-even cost is less than 0.35. With Luna Experience, with the prices that is currently available in the market, they are likely to break even, provided the cost of the sunflowers is competitive. So this is what it looks in a field. This picture was taken out of Grandin. So under the no fungicide control, you can see the browning on the sunflower stems. The heads are starting to fall off. They are signs of Phomopsis. Again, this was about 1.5 months prior to harvest, and compared that with a pyraclostrobin application with the Luna at R6, we are definitely able to tell the differences between like when a fungicide is sprayed and fungicide is not sprayed. And this trial was purely on susceptible hybrid. The ground that was picked up had a history of Phomopsis stem canker, so we knew the disease was already present. So just to summarize, we are seeing there is hope in managing fungicide resistance, because we are definitely looking at a chemistry that does not have QI. So our hope is that in years to come, we are able to recommend to the farmers that 1 application of QI at R1 followed by the triazole plus STHI combination can at least yield greater when compared to a no fungicide control. What is pending is we are still waiting for the data from 24 trials, and also to be able to set up these trials in areas where we did see the QIs may not be effective. So we do have some specific locations that we would like to continue trying these fungicide trials in the years to come. With that, I want to acknowledge the Sunflower Working Group. We are really a small group of researchers on sunflowers. Many of us have part-time appointments, but we work very cohesively. We do have an international group among the researchers listed here. I'm not going to take everyone's names, but we have a lot of people that we work with who has worked with us, our former students, our research specialists, undergraduate students, and farmers, the industry. We all come together as a group to be able to establish research like Phomopsis. So with that, I quickly wanted to acknowledge our funding agencies, the National Sunflower Association, South Dakota Oilseed Council, USDA, the USDA NIFA CPPM through the NCI-PMC for funding all our extension activities. And the research side is funded by USDA NIFA CARE. And we are greatly, I'm also grateful to Mrs. John Swanson for helping me out with the webinar today, and also for those that were listening. So with that, if you have questions, please feel free to ask. And I didn't see quite the poll window, but I'm guessing that the polls would be showing up. So if you get a chance to see the polls, please fill it on the go. Thank you.
Thank you so much, Fabina and John. So yeah, you can go ahead. I think the poll questions will launch. You can go ahead and answer those as they launch. I guess, in the meantime, as a grower, I guess how widespread, and anyone, please put in questions in the Q&A and I will read those questions, and then Fabina can answer them. So as a grower, is the resistance widespread? Is it the point where you recommend doing the second spray, or is this a case where test, or I guess how as a grower, how do you know if you've got resistance or not?
So usually, for fungicide resistance, it's a little hard to tell for Phomopsis because we spray at R1 and we actually start to see the symptoms at R5. So, the fungicides typically sprayed at R1 will have only a 14-day window when it is active, and then it starts to break down. So then Phomopsis starts to show up at R5. So currently we are looking at a second application that can show up at R5. If there's any quick way to tell if you have dealing with a fungicide resistant strain, not really. So what we are doing out there is, if someone reports back that, okay, my fungicide's not working, regardless of the sprayer, ground or aerial, I usually ask for those samples, and then we just, we run the traditional method of extracting, isolating the fungus, extracting the DNA, and then running the molecular assay. And John, I'm going to open it up to you if you had another perspective.
Well, can be very economically limiting. So farmers to date are not real familiar with putting on fungicide for Phomopsis as a general rule. Some of us have tried it off and on, and we've had it with mixed experiences of control and not control. But in general, I kind of did a study where growers that put it on and didn't put it on, and that was my question that I asked. And then if so, what was your yield? And I found that we had about a 300-pound increase by using headline. So there is response, and at 300 pounds, that's normally economically viable to spray. The challenge is you don't see the problem before you have to spray, so you have to do it proactively prior to getting the disease. And if you're in an area that has high disease, I think it's recommended to at least consider spraying as a insurance policy.
And forgive this question, I'm not a pathologist, but does this overwinter then in the field? Does it spread much to if you've got a resistant strain going, is this likely to spread or build up over time?
Yeah, so Phomopsis has got a very broad host range. I mean, when we talk about specifically species causing disease on sunflower, it can infect soybeans. It's some work that we showed in North Dakota. It can also be an endophyte on weeds, meaning the weeds are not going to react by its presence, but it can still live in the weed without doing anything. But I think just recently when we were down in South Dakota, just like a week or two ago, we started to see the Phomopsis starting to show up on the wild sunflowers. I had not quite seen that, but I remember some of the specimens were sent to my lab. So weeds are very common. It can overwinter on the residues. The only two crops that I know that it probably doesn't infect so much, and I'm talking only about the field crops, would be wheat and corn. All the other crops that we know could host the genus by itself, or it could be even those specific species that infect sunflowers. So having said that, even if it's a QI resistant strain, we are still going to see it live through like any other normal strain, like like a wild strain. So it's going to live through the residues. It's going to be able to cause disease. And, one of the key things that we are working with is developing resistance. And we continue to screen lines from the breeding programs from the USDA ARS sunflower unit that's in Fargo, as well as for the industry. And so that's probably our long-term shot to find a solution to the Phomopsis problem.
And I'm not positive that we had it ever played it out or seen it on certain types of pigweeds. I've seen what certainly looks like Phomopsis.
Sure. Yep, good point.
Interesting. So there's a possibility that the resistance, it could be getting exposed to fungicide in other crops as there have fungicide being used on them, because it could be even on weeds and
Yes.
other crops. Okay.
Yeah, it could be like a sort of like a spill. And so it could be like, I mean, sunflowers are typically rotated with wheat or corn, but there's always, I've seen like, for example, soybeans growing adjacent to it. So if there is some applications happening, the cure chemistry may not be directly sprayed on the sunflower, but there could be some fall that can happen on the fungus because it's just everywhere.
We had a comment that the 6 ounce of headline grower price has dropped to around $7 an acre for the return.
Yes. Yep. So yep, the fungicide prices are continuing to decline. The headline is something that is now probably off the shelf. It's mostly Preaxer and the other QI products that are coming out. But yes, that's a good point. The fungicide prices are hopefully trying to decline, which will kind of push up the return on investment for farmers if they were to consider the use of fungicide in sunflower production.
I don't know if you can see the chat as well.
I was just going to say there's a second poll that's out there for the audience. So adding 2 ounces of Preaxer to sunflower herbicide for plant health and disease suppression. That's really great. We are getting to see good results on adding Preaxer to the tank mixing Preaxer with the herbicides at V6 to V8. Yeah, we still have to check to see if they are efficacious against the Phomopsis stem canker. So, one of the things that is pending is where we want to tank mix the fungicide with insecticides or herbicide. We haven't purely done that part. A lot of our studies have pretty much is just on fungicide by itself, and that's what we are looking at.
So audience question too, I'm not sure if you can see the answers, but what impact has the emergence of QI resistant strains of Diaporthe had on sunflower production?
Right. So yeah, it says decreased efficacy of the current fungicide treatments and increased severity, high yield losses. It's technically it's all of the above. We just basically starting to see some of the chemistries break down, and some of them has probably not even working, like so the QIs, and that's something we've noticed in our trials down in Brookings. But this is good information, Mike. Thank you for sharing. So we have the third poll. So we do talk a lot about, I'm almost giving the answer for this. We do talk a lot about IPM when it comes to managing diseases in sunflowers. Again, we do have limited chemistries, and we try our best to, work closely on host resistance. The unfortunate part about developing resistant hybrids is it takes a very long time relative to wheat to get the hybrid released in the market. We're looking at least 10 plus years. We're still trying to improve the breeding tools that's available for introducing these new varieties, but it's been a slow process. And I say slow again relative to the other field crops. Granted that the sunflower is definitely going to be very different from wheat genome and so on. The sunflower genome was just made available in the last 3 or 4 years, so it is again relatively new, and we're still working around to develop new technology. But the audience says by combining multiple strategies, and I fully agree with it. It includes education as well as whatever we do have. So we did talk about fungicides, we did talk about resistance, host resistance, but weed management is equally important. We do have limited herbicide chemistries, but that's where the data from Mike comes handy. So there is some promise that there's a lot of herbicide. There are options for herbicides that farmers could bang on to control the weeds. And that is very important because weeds are a great reservoirs for these Phomopsis species.
Are there different hybrids that are, was it confectionery was the term versus oil? Are those different hybrids or?
Yes, so we do have two types. There's the class types. So we've got oils that we pretty much use for like oil for cooking, and then confections is what we use as snack in our feed as well as bird feed and so on. The breeding programs tend to be a little different for oils as well as confections. Currently, a lot of the emphasis is on oil seed hybrid because that's what we largely grow here in the Dakotas and Minnesota. So we're trying to look for resistance to the oils. Confection production has slowed down over the years. But I don't know, John, if you have information on if they are breeding for resistance in both the classes, or is it just that oils probably get a little more weight than confections?
Well, it's more difficult to put it into confection, and there's less programs working on it. But there's a third class would be con oils, and that will be a confection times an oil. And that's become a pretty large portion of the market that's used for snack food, and especially for salad bars and for the baking industry. And we can bring in more resistance from the oil type to the confection by making those crosses. And actually there's some heterosis that occurs that gives better yields too. So for the hulling market, it's gone to these con oils versus the traditional confection.
Testing.
Yeah.
We had a question in the chat probably for you, Fabia. Do you know the effectors of Diaporthe helianthi?
So I believe we're going to be looking at it. We do have the sequence of Diaporthe helianthi, like sequence of the genome sequence of the Diaporthe helianthi available. Like it's my hard drive, and we get to do the and sort of like the bioinformatics analysis to see if we can identify some virulence factor that may have a close match with what we know for other Diaporthe species or what has been reported in other pathosystems. So we're working on it. We don't have an answer for it like today. But thank you for the question, Eileen. And with that, we have the fourth poll. How can extension services best support farmers in managing fungicide resistance? All right, so 71% says all of the above, which means providing training on new fungicide options, also offering any sort of field-specific advice on IPM, and also having access to, didn't see anyone on access to research findings in resistant hybrids. But we tend to do a lot of that through our stakeholders, National Sunflower Association, the Minnesota Oilseed Council, Sunflower Growers, the South Dakota Oilseed Council. We do talk to the board of directors directly. We also have the Sunflower Forum that is hosted by the National Sunflower Association. So through our stakeholders, we do try to explain or describe our research findings. And we also have a magazine called The Sunflower that publishes a lot of what we do for research. But I do agree that whatever we could do to get the information out to the farmers through extension services is always a bliss.
Very good. I don't see any other questions or anything else that either of you would like to add.
So I was, again, going to thank the funding agencies, really grateful NCIPMC for giving us the opportunity. And John, thank you so much for throwing in your perspective. That always helps to understand how it, how the diseases could be sort of like a limiting factor when it comes to production. Sunflower, of course, being a small crop with Phomopsis doing its thing for the last 10 years, 15 years now, and not being able to find solution. We do have a lot of work to do, but we try to do it as much as we can and also work with stakeholders. So it's all a very wonderful experience trying to share the findings with you all, and also trying to learn more about it from the others. So thank you so much for the opportunity. Really appreciate it. And for the last call, I just wanted to quickly thank all our Sunflower stakeholders, as well as the 2 USDA NFA programs for the funding that they have provided us for years.
Thank you. Thank you both. Yeah, we really enjoyed the sunflower working group. It's a fascinating crop and great research being done.
All right. Thank you.
Thank you
Laura.
so much. Thank you both. Thank you, John.
Thank you.
Thank you, John.
Our next Pests in Progress webinar will be on Wednesday, October 16th. We don't have one for September. It's kind of a busy month. So on October 16th, we'll have prediction and management of Asiatic garden beetle, pest of corn and other field crops in the Great Lakes region. Kelly Tillman from The Ohio State University will be giving that presentation. So we look forward to seeing everyone in a couple of months, and have a good rest of your month and start of the school year for everyone.